Lesson 14.1, represent decimal addition. I can use concrete models or drawings to represent decimal addition. Spark your learning. A baker puts the flour onto a food scale as shown. What will the scale read if the baker adds another 2,900 pounds of flour to the bowl? Use a visual model to help you find the weight after the baker adds 2,900 pounds of flour to the bowl. Draw to show your thinking. Okay, so basically in the first one, it's out of what? What's our highest place value? So on the scale, what's our highest place value? Tenths, right? So we are going to draw a square and break it into 10 sections. 4 tenths, right? Okay, and then we're going to color in how many of those sections? 4, right? So lightly shade in 4 sections. Okay, then the other one, the 2,900, what's our place value? What did I last say? Hundredths, right? So then we're going to have another square. And we would break it into 10 this way. And then we'd also break it into 10 this way. Okay, so we do that. And then how many do we have? How many tenths do we have? We have 2, right? So we color in 2 full bars. And then we have how many of the third one? 9, right? So we color in all but one of them from the third bar. So how many, so if we were going to add this together, do we have any full flats? No. So we put 0. How many longs do we have that are fully colored in? So 4 here, 2 here, so 4 plus 2 is 6. So 6 tenths, and how many small cubes or small bits do we have? 9. So our answer would be 6,900. And then we have to make sure we correlate with the 6,900ths of a pound. Build understanding. What will the scale read if the baker adds another 8 tenths of a pound of flour to the bowl? Use base 10 blocks to help you find the weight after the baker adds the flour. Let one flat represent 1 whole and 1 long represent 1 tenth. Do you think the weight on the scale will be less than or greater than 1? It'll be less than or greater than 1? Greater than, okay, so greater than, because 8 plus 3 equals what? Equals 11, okay? So what base 10 blocks do you use to show 3 tenths and 8 tenths? So we would use what? How many longs? So what was it originally? 3. So 3 longs. And then how many other longs? And then 8 longs. What do you get when you add the tenths? So how many total longs do we get? 11 longs, which equals 11 tenths, right? Okay, so do you need to regroup? Explain. Would we regroup? Yes, because 10 longs equals what? It equals one whole, or in this case, one flat, right? Because these are called flats. The hundredths are called flats, okay? So, and then we'd have what left over? So we'd have one flat and plus one long, right? Okay. What is the weight after the baker adds the flour to the bowl? So one flat equals what? One whole, we said, right? So that goes in the one spot with the decimal, and then how many tenths do we have? We have one long, so one. So 1 1/10 pounds. Number 2, the baker puts dried fruit onto the food scale. The scale reads 1 86/100 pounds. What will the scale read if the baker adds another 1 28/100 pounds of dried fruit to the scale? You put pictures to help you find the answer. So you have our 1 86/100, 1 28/100, and then they want to know what the scale will read after that's added. Okay, maybe we showed you that 1 square is a whole, so that's in the 1 spot, right? A long is a tenth, right, or a stick, and then a dot is 100, or a small cube. Okay, so if we had our manipulatives and stuff like that, this would be the flat, this would be the long, and this would be the small cube. Okay, so draw a quick picture. So 1 20 or 86/100. So we have how many flats? 1, right? And then how many longs? 8, right? And then how many small cubes? 6, so 6 little dots. Okay, plus how many flats for 1 28/100? 1. How many longs? 2, and 8 small cubes, right? Okay, how can you regroup the place values shown in your picture? So basically, do we have to regroup the flats? No, so we can go ahead and draw 2 of those. Then we can lightly mark off that we've already used those, right? Okay, now how many longs do I have here? We have 8 here, and how many do I have over here? 2. So if I put those together plus this, and I grouped those together, how many do I have now? 10. So I can draw another flat down here, right? Because the flat has 10 longs in it, right? Okay, so I used this. Now, in order for me to get a flat, not a flat, a long, how many do I have to have in it? How many small cubes? 10, right? So I have 6 here and 8 here. Can I do that? Yes. So I can take 2 from here and add it to this over here, right? And then that gets rid of them, and I need to draw what down here? A long, right? Okay, and then how many small cubes do I have left? 4. So 1, 2, 3, 4. Okay, so now what is the weight of the dried fruit on the scale? So how many flats do I have? 3, so that goes in the 1 spot with the decimal. Then how many longs do I have? 1, that goes in the 10th spot. And then how many small cubes do I have? 4. So 3 and 14/100 pounds. Check understanding. At the store, Joe buys 8/10 of a pound of white mushrooms and 2/10 of a pound of brown mushrooms. How many pounds of mushrooms does she buy? Draw a visual model to answer, or to find your answer. So 8/10, 2/10. So what do I need to draw for 8/10? 8 what? 8 longs for 8 sticks. Okay, how many longs or sticks do I need to draw for 2/10? 2. Now what can I do? I can group all those together and they equal a what? So basically, I'm going to cross this out because I have to replace it with a flat. Okay, so my answer is what? 1 pound. On your own, number 2, the digital caliper shows the width of a foreign coin at 25 and 75 hundredths milliliters. What is the combined width of these two coins? Okay. Okay, so basically we have 2 of the 25 and 75 hundredths, right? Okay, so I could technically just line up my decimals and add it, okay? So let's go ahead and do it that way. So 25 and 75 hundredths plus 25 and 75 hundredths. So put a decimal. So 5 plus 5 is 10, carry the 1. 1 plus 7 plus 7 is 15, or 15, sorry, carry the 1. Then 1 plus 5 plus 5 is, carry the 1. 1 plus 2 plus 2 is, so 51 and 50 hundredths millimeters. And we could have drawn pictures, right? Okay, but that's all right. Okay, number 3, attention precision. A runner's first sprint time for a 100-meter race is 10 and 76 hundredths seconds. The runner's second sprint time is 10 and 85 hundredths seconds. What is the combined time for the 2 sprints? Which place values require regrouping? So once again, we're just going to work it out. Okay, and then on the next one, they want us to draw. Okay, so, and then they also want to know which place values we had to regroup. So 10 and 76 hundredths, and we line everything up, plus 10 and 85 hundredths. So put my decimal. 6 plus 5 is 11, carry the 1. 1 plus 7 plus 8 is, carry the 1. 1 plus 0 is, 1 plus 1 is 2. So our answer is 21 and 61 hundredths seconds. And which ones did we have to regroup, guys? The tenths and the hundredths, right? Tenths and hundredths. Okay, so draw a visual model. All right, so 1 and 500. How many flats? 1. How many longs or sticks? 0. How many small cubes or bits? 5. Okay, plus how many flats? None. How many longs? 2. And how many small cubes or bits? 5, right? Okay, so this equals, okay, so basically we work backwards. We work from the tenths and then go to the flats. Okay, so small cubes and then go to flats. So how many small cubes do I have? 5 plus 5? Okay, so I can take these and add them together, right? And that gives me one more what? One more stick or a long, right? So how many longs do I have? 3. And how many flats? 1. So I get rid of everything. And don't forget, if you add those together and group them together, you need to cross them out so you already used them. Okay, does that make sense? Okay, so what does that equal? 1 for the flat, and then longs, 3 tenths. Okay, next one, how many flats? None. How many longs? How many small cubes? Okay, plus how many flats? None. How many longs? 4 or sticks. And then how many small cubes? None, right? Okay, can I regroup anything? How about my small cubes? Can I regroup anything? No, so there's just 4 small cubes, right? Okay, my longs, can I regroup anything?